Hey guys, if you're watching this video, then you're probably a beginner learning programming. If you're not, if you know your way around programming but you're new to Godot, then this is definitely the video for you as well. I'm going to go through the basics of Godot, basics of programming, and try and teach you how to make your own game. Not just walk you through step by step, but actually explain stuff to you as well along the way. If you enjoy this type of format, this long form video, then that is great because I'll be doing more of these. This isn't the only episode. I'm going to record multiple episodes in this series. Today we're going to focus on the character, so apologies for any audio issues as well. This was recorded at my local university, and I might have been facing away from the microphone for a bit, so apologies about that. Enjoy. So we're obviously starting off at the beginnings where everything begins. Our Godot engine I hope you guys have downloaded. If not, you can come to the official Godot page to get the release. I've already downloaded it, so I have it ready to open already. So let me just get that one open and bring it over. So we're going to start off pretty much from scratch, a new project. This is going to be what you're going to see minus these two. These are my other projects that I have. But yeah, we can come to create, new project. I've got a structure already that I want to kind of start off here, but you would come to create. Oh yeah, okay. Never mind, we'll do create because I haven't got the file yet. But if you come to browse, you can find your own folder or make your own folder. Here we go. We'll select this folder, and I'm just gonna double check. Yeah, that's. Oh, it's not empty. That's fine. We can just really quickly make an empty folder, and we'll just name this tutorial series. Okay. It'll open up a new window for you. So let me just drag that across. This is what you're gonna be looking at pretty much for your Godot project. It's a little bit squished in, but I imagine on your laptops it will look a little bit different. So first, in any Godot project, it's really important to understand the UI of Godot. It's more node-based than other game engines. If you would have done Unity programming before, we still have like the concept of nodes, but in Godot it's really heavily reliant on them. So what we can do to create our first scene is I always go up here, create a child node. You can do Control A, same thing. And this is the base class for all scene objects. So I always have this as my root node because, in most scenes, if you're doing 3D, 2D, you'll work with everything. It's just an object that we can have children off of. So we'll name it world. We won't name it world apparently. We'll name it world now. And yeah, this is going to be, we're going to attach a script onto this. I won't get into that now, but if you have more complex projects, then you can think of your world node as like your global script, and it's going to hold all your variables. But yeah, we're going to make like a 2D top-down character first today. So there are a few nodes that actually come under that category. If we just type in character, we can see there's a character body 2D and 3D. We won't touch the 3D one today, but it's fairly similar in terms of functionality. So you double click that or click enter. It's going to be our character. We can see our character, nothing has happened, and there's a warning symbol. So the warning symbol pretty much means there's no collision shape tied into that. We don't have an image for our character as well. So first of all, I would suggest creating an image for your player. Let me just move the mic because I'm looking to the side a lot. So to create an image, it's called a sprite in Godot, and our sprite has a texture property on the right panel. So the right panel in Godot is all of your properties of the node that you've selected. If I go here to select a different node, you'll see the properties change. So you've got to make sure the Sprite 2D is selected, and then you can drag on your icon.svg across. Now we've got an image on the screen. This is going to be a placeholder thing for us right now, but in the future we can create our own textures and our own characters. but since that icon is just in our default Godot project, we're going to use that. And then now we've still got a warning symbol, and it's saying consider using a collision shape 2D or collision polygon 2D as a child to define its shape. That pretty much means that we need a bounding box for the player, and we're going to add a collision shape 2D. You could add polygon for a little bit more custom if you have like a more detailed object, or more detailed sprite I should say, but for us it's just a box pretty much, so we don't really need to do that. In the right panel here, we can add a rectangle shape 2D or a circle shape 2D, depending on your character and how accurate you want it to be. But yeah, we've selected rectangle for now, and it's a little bit small, so we can size it up a little bit by dragging the corners across. If you want it to be doing the same on both sides, you can hold Alt to drag it symmetrically, and then Control, actually no, there's no Control, just Alt to drag it symmetrically and kind of have a nice symmetrical box for your character. Now there's no warning symbol. So this is like what you're going to do first in Godot. You want to build out your scene first, and then you can add the scripts after. So once we've got that, I actually do want to import a image that I have as a background. It's in the file, but I need to drag it into the project. So importing anything into Godot is really easy. You see this res folder on the bottom left here. That's going to be your root node of all your assets, and then underneath that you can kind of segment it out into your project structure, which is really important too. So let me just get this background. I'm actually going to start by creating a folder before I import my background. So you can go here, create a new folder. Let's name it assets. I like to structure my project like this. I like to do assets folder, a scripts folder to hold all of my code, and then finally a scenes folder, because when you build in Godot, you usually create a lot of scenes, and I'll get to that in a bit. All good if you don't want to have this, like this is just my personal preference. And then I'm going to drag in my background.png file into the assets, and it will just import it automatically. I have this background if you want to use the same one in the Discord server. So if you want to use the same one I'm using here, you can go ahead and import that. But if we drag the PNG right into canvas, you can see it's created a sprite for us automatically. I'd say that's pretty good. We can leave it as a sprite node. That's fine. You'll notice if you look at the scene, there is a faint purple outline. That is our current screen resolution that we've got set to in project settings. So this actually covers our screen resolution. It's bigger. If you guys want to have your game default to a particular screen resolution, you can come up to project settings, and then if you scroll all the way down to display window, you can set the size here. So right now it's less than 1920 by 1080, so my window is actually 1920 by 1080. For now though, I'm going to keep it to the default, just letting you know that's where the settings are, and for now it doesn't matter where our background is. So where's our player gone? Where is it? It's over here. Currently the reason why it's not showing up is because of the way nodes work in Godot. Everything at the bottom of the tree or the child list is going to appear over whatever is above it. So to change the order, I can just drag it, and there we go. Additionally, if you want to manage precisely what order it's going to go in, you can scroll down on the properties tab, go to ordering, and then you can change your Z index, which is how high, I guess you could think of it as a Y axis. If you think of it 3D wise, your Z index. So higher Z index will appear over the low ones. But yeah, that's going to be our basics for the scene for today. And then we can kind of get into the code. So let me know if I'm moving too fast as well. I can definitely slow down and explain if you guys have any questions. But for now, we are going to add into our character body 2D script. So we can come over to scripts like we've created before, and I don't want to name it. I don't like naming it the default file or the default name, because it does get a little bit confusing. So we can just say player top down or something along those lines. Click enter and then create. So if you didn't touch any of this other settings, you'll notice, and if I bring this a little bit, make it a little bit smaller just to read the code a bit, you'll notice it already has code here, which is not the greatest for our case. It's going to be pretty much like a platformer basics. So if you're not using platformer, if you're not making a platformer, I would consider deleting this. I'm going to leave some stuff up here, speed, but that's pretty much it. So everything above, or every script in Godot has this extends and the name. The name is going to be a native class that each Godot node has. So this refers to the character body 2D that we've created here. If you attach a script that doesn't extend from the same class or a parent class of the node, then it will not work. So you need to make sure it's either character body 2D, or if we control click into this, you can see it inherits physics body 2D, collision object 2D, all of these stuff. Pretty much, you could use any of these ones, any of these names here, and attach it to the character body 2D, but in most cases, you want it to be the same name. So our character is going to have a speed, obviously, of its movement. I'm actually going to tweak this and make it like 1,000. And then we're going to have an acceleration value. I'm using capital letters in this case because these are constant values. If you've done programming before, then you would know that variable naming, always we use capital letters. So I'm doing a semicolon here because in Godot you can use inferred type, which is the same as Python, or you could use static type. So I like to do static typing in Godot, at least for me. It doesn't really influence the runtime of it, but later on down the track, you can have like type hints, and that's really helpful for me at least. I can see if we've created like a custom class, I can see what methods are in the class and autocomplete that. So I always do statically typing, and our acceleration is going to be a float. So, and I'll just have that at 5 for now, I believe. I just remember what values I chose before. Actually, kind of. Okay, yeah, 5. Okay. You can do what I've done at the top here, when I just do the semicolon equals. That lets Godot choose what type it is automatically. So I've got 1,000.0, so it's going to choose a float. These two lines pretty much do the same thing. It's just depending on whatever you prefer to look at. I prefer the bottom one. Now that we've defined our constants, we're going to define a variable, which is this var keyword. Var, and then we'll have a name input, and then we'll have a type vector 2. This one you cannot do just like the semicolon equals because we don't have a value for it yet. There are some functions in Godot that I mean, if you guys have done Unity, it's like our I actually forgot the name for it in Unity, but it's our regular routine functions. So there are a few of them. Ready? This one will, oh, I didn't underscore already. Okay, here we go. So yeah, this is going to happen whenever the script is loaded for the first time. This is going to be used heaps in your projects, just not in this case. So we can comment that one out. Another really important function is process. This happens every frame. So if your frame rate is 60 frames per second, it's going to run 60 times a second. We have a similar version of process called physics process, let me just comment this out for a second. Physics process is very similar to process, but it specifically handles the physics side of things. So if you have a rigid body, which is like it's similar to a character body, but it can be moved around by physics forces and interact with solid objects and stuff like that, then everything will happen in this function.
It's basically the same as like update, fix update.
Yeah, pretty much. Update is the same as process, and then I can't remember if there's a physics update in Unity or not, but
That's what fix update.
Oh, fix update. Yeah. So pretty much exactly what Mitch said. It kind of maps to that one by one, and then ready in Unity is, I think it's start. So start, same as ready.
It's like so.
There's like awake, enable, start. I'm pretty sure it's start is the same as ready.
When does this work?
Ready goes, I think, whenever the script is loaded for the first time. I can't remember what start was, but I remember somewhere in between awake. Oh, okay. Maybe it might be awake then. But those are going to be your main functions. For now, we'll do another function called getInput. This is going to be our custom function for now. And this is, the aim of this function is going to be to return a player input. So our name of the function proceeds, and then there's an arrow that you can do. This is not, you don't have to do this arrow here at the end. It's just going to tell the compiler what the return type is, and we want to return a vector 2. Alright, you can leave it out if you wish. And for the input, actually what we need to do is we need to first come to project settings, and then on this tab, input map here. So our input map is currently empty, but what we can do is we can add keybinds or inputs. So any top-down character controller is usually just going to use WASD movement, or maybe the arrow keys as well. But we'll just create our up-down, left-right with our WASD. So we can click plus once I've typed up, down, and click enter or plus, left, and right. To actually add the keys to this, we click the plus on the right hand side, and I'm doing up first, so I can just type in W and it will come up. There's another way to do it though, so I'll show you really quickly. If you go to keyboard keys, you can open up this drop down, and you can actually find what key you're going to look for. It's pretty annoying to do, so I just like to type in, oh, that's not right, filter by event, S. We're going to do the same for the other ones, left and right. A is left, and for our right, it's going to be D. So you can also map controller controller inputs really easily to this as well. If you go to the plus again, there are joypad axes and joypad buttons. So usually you're going to use your left stick to move around if you're using a controller. So left stick left is going to be your left stick pretty much going left, and that's probably, we'll map that to our left. I'm going to look for the up, so left stick up here, it's going to be our up movement. Godot handles this really well for all controllers, so it will just work with any controller that you connect pretty much. And then we're doing down, so left stick down. We'll just continue doing this for the other ones. Did you have a question before? I saw... Yeah.
It's there, so let's say 1 is to press up, down, right?
Yeah.
There's building that.
Oh yeah, yeah, UI up.
Cited input that. It shouldn't usually work, but there's
Yep. Yep, that's exactly right. Yeah, I think what we're talking about here is the UI inputs. That's by default. Godot has, yeah, UI up, down, left, and right. We're creating custom ones here because I wanted to also implement controller input, so it'll work with your controller. But yes, you're actually right. This toggle here shows built-in actions. We have a lot more built-in ones here if we scroll down. There's so many. So I think if you use the up key, then it's going to say, yeah, here. It's going to contradict with UI up. That contradiction will only happen if you connect UI up to another function, so it actually won't really matter too much. The UI up is called if, say, we've selected a UI element and we're trying to navigate it using our arrow keys. But usually when we're doing gameplay, it wouldn't be affected. For the final one, we'll just connect the left stick right here. Okay, and we should be done with that. We can close that. Okay. Now to actually return an input vector, we need to get these inputs that we just created. So we can name input.x. This is going to be our, oh, actually, we'll create a new variable here. We'll say like key, maybe not key, direction. And we'll have it as a vector too. And we don't really have to initialize it yet because we're going to do it in the next line down. We can say direction.x, so direction as an x and y value. Direction.x equals input.get action strength. So input is a native class in Godot, and then get action strength is going to return a value from 0 to 1 based on how hard the key is pressed. On keyboards, it won't really matter, it's only going to be 0 or 1, but on the controller, it's going to be a variable because you can move the stick slightly or all the way. So yeah, we're going to have that as right. Oh, I need to have quotation. Right. And then the x needs to be, or the right needs to be subtracted by the left. So we can copy the input.getActionStrength. I've spelled that wrong, sorry. And I'm just going to press tab to autocomplete, and yeah, we'll do left. Okay, so that's our direction X. So the reason why I'm doing right minus left, the way Godot considers what's positive and what's negative in the X coordinates is a little bit different than regular. So right is considered positive. If we move the character right, it's going to have a positive X coordinate, and if we move it left, it's going to have negative. If we move it down, it's going to have positive, and if we move it up, it's going to have a negative. So it's slightly different to our regular Cartesian coordinate system. And then we can have our direction.y equal to our down minus our up. So we're going to copy the top line. Actually, we can probably, if you guys want, you can Control C, Control V, so I don't have to type all that out again. And then we'll just swap right with down, and we'll swap left with up. So it's always going to be the positive coordinate, what I was talking about before. Right is positive, down is positive. Positive coordinate minus the negative direction coordinate. Alright, that's our main calculation for that, and then we can just return our direction vector. Okay, just before we do this, the reason why I'm stopping here is if we have a positive right direction and it's just value of 1, direction.x is 1, and direction.y is down, and it's 1, that's going to have a normal or a length of 1.41 roughly, just because our if you think of the right-hand triangle, both shorter sides are going to equal 1. So what we can do is we can normalize this vector. That means that our character will move the same speed on any axis, so we just call dot normalized. And that function normalizes the direction just in one line. Alright, that's how we get our input. What we can do now is we can make a new function called process. This one is our physics process function, what we were talking about before. It's going to get called every frame. And for the code in it, it's actually pretty simple. We're going to store our play input in... actually, I've written this a long time ago. We don't actually need this this value up here, this input value. We can delete that. We can delete that. Play input. I'm really bad at spelling. And that's going to be the vector 2 that we were talking about before. Wow. I am missing all my characters today. And then we can call getInput, the function that we just created before. Alright. Let me just scroll down a bit. It's getting a little bit cramped here. I'll play input. Then to actually make the character move, this is going to be the line velocity. So each character body 2D has this property called velocity you can change in code. And we are going to set this to our player input pretty much. If it's positive and positive, it's going to move bottom right, negative, negative, top left. You get the picture. But this is not enough. It's going to move really slowly. What we can do is we can multiply it by our speed up top, and then we will get pretty much a basic character working. There is a few more things I do want to say though. If you want your character to look smooth and not just snap to each axis, what you can do is we can call lerp, which stands for linear interpolation. I use this all the time when doing stuff like this. And if we hover over lerp, we can see it gives us a whole lot of information. So it's saying that it linear interpolates between two values and by the factor defined in weight. So our weight is going to be, in this case, acceleration. The from, though, is going to be our current velocity. So we obviously want velocity going to be the first argument. If you want to see kind of the more details in any sort of property or function, you can control, hover over the keyword and click, and it opens up the documents in Godot's editor. So that's really handy. I use that all the time. Even now, I see a lot of weird classes that I didn't know about, so I like to come to that. And then finally, we're missing the third argument, which is going to be our acceleration value times by delta. The reason why I'm timesing by delta is the time in between each frame. So if you're running at a higher hertz, if your monitor is like 144 hertz, this is going to make sure that the character moves the same on all monitors, not just going to give everyone an advantage if they have low or if they have higher frame rates. So that's why we times it by delta. And then finally, we need to call move and slide. This is a inbuilt function for the character body 2D. You can see up here, character body 2D.move and slide. This just enables that the body will be updated from the velocity property. And we call that at the end of our process function, always. This is all we need to make a top-down character. So what we can do here, we're going to hit Control S on our scene. We're going to save our scene in the scenes folder that we created earlier. If you haven't created it, you can create it now. And I think we'll just stick with world.tscn. Seems good. Alright, to run our project, we come up to the top bar here, run project or F5. You can hit either key, and it's going to give us a confirmation bar. No main scene has ever been defined. Select one. You can change it under project settings. We're going to select the current one because that is our only scene. But if you have multiple scenes, you can select one in the menu. Alright, and this is what we get. So if we try and move our character moves around. Yay! And we can see where it is. So if we go off the screen, our character's going to get lost. So we can do some trickery later on to make sure our camera actually follows the player. But this is what you're going to be seeing. This is the bounding box of our world currently. Okay, I think we'll do the camera next. Just scroll down. Okay. Let's have a quick drink. To make a character follow around the screen, we can add what's called a camera node. And usually you have your camera node as a child of the character. So child just means it's underneath the character. It's going to get followed. It's going to inherit the position of the character and the scale and all of its transforms. So we obviously want the camera to follow around the character. So we can do a camera 2D node. And we have a bunch of properties that we can tweak in the camera. If we zoom out a little bit, you can see this bright pink rectangle. This is going to be what the camera sees instead of the dark purple rectangle that we were seeing before. That's what the scene, or that's the window size. This is what we're going to be looking at. You can change the zoom value here if you want it to be a different value. So say 0.5 is going to be way zoomed out, or if you want to make it a lot closer, we can increase this to 2. Up to you guys. I think 1 looks pretty good for now. There are a few position smoothing and some other values that you can tweak. So I like to have positional smoothing on because it enables the camera to kind of lag behind a tiny bit. It seems like someone's holding a camera and trying to track your character. I'll show you what that means in just a second. So now if I move, you can see the character moves first, and then our camera kind of pans down. I quite like this effect, but if you think it looks a little bit too delayed, or if you're not the biggest fan of it, you can tweak it and you can make it a little bit smaller. So, oh my goodness, let's stop that. We can change the speed to maybe 10, make it twice as fast. And then this will actually, I believe, sync. Yeah, this syncs in real time, so you don't need to close the project every time. This is going to make the camera kind of snap a little bit closer. But this is all we need for a camera following the character. Okay, let's go back. In the next tutorial, we're going to work on the background and make it repeat and not just stop at this corner. But for now, that background's just there for a visual aid to see the boundaries. Alright, I mentioned earlier there are 2 types of characters. The physics-based rigid body and the character body 2D. So we're going to actually look at the physics-based one next. How are we doing for time? Good. Oh, I'm typing the wrong one. It's called a rigid body 2D. Same setup as the character, pretty much. We want a sprite scene, a sprite child, I should say. We can actually drag the icon. Oh, we can't. We can drag the icon into the scene, and it will add the sprite automatically. And then we can just make that a child by dragging it onto the rigid body node and deselecting it. Now, I will say this icon isn't centered properly because the rigid body is at 0, 0, and this icon's all the way to the side. So we do need to fix that. Pretty easy if we come over to transform here and just click this reset. Alright, goes back to 0, 0, centered properly, and the warning is telling us again we need a collision shape 2D or collision polygon 2D to define its shape, which is fine. We can create a same thing as before. We're going to come to collision shape 2D and create a new shape. if you want, you can copy and paste your rectangle from before. I'm doing it the slow way. I didn't think about it before, but hey, good practice, right? Oops. Accidentally hit Windows. Okay. So, we've satisfied the node requirements. We can come back to the script. Or actually, a few more things I want to say. Rigid body 2D, there is a few properties you can tweak here, like the mass, the gravity scale. The physics material, this will make it like a bouncy ball if you add a custom physics material. We're going to leave that except for the gravity scale. Because we're a top-down platformer, we're pretty much not dealing with gravity at all. If we do have the gravity on, then our character's just going to fall down and plummet to the bottom of our screen very quickly. So we can set our gravity scale to 0 to stop that from happening. Then we can come to the script and we'll add a script. I'm going to navigate back out of my scenes tab into the scripts, and then we'll say maybe like physics player as the name, and create. All right. So for our rigid body 2D, what I want to do as the movement, instead of using our keys like we did before, I want it to follow the mouse. So we're going to have our mouse on the screen, and it's going to our player's going to follow around the mouse. There is a really simple way that we can do that in Godot as well. So let me just delete the current functions in this class, and we're going to start up from here. So we need our acceleration and our max speed, same as before. What we can do is, before we had it as just constants, but I'm going to show you guys the export keyword. So if we come over here and click at export, it's called an export variable. It's going to be saved to our disk, and it'll be viewable on the right panel in the inspector panel. This is really, really good for things, for values that you want to tweak, and you can tweak it really easily by just changing it, dragging a slider most of the times. So we can go export, and then I'll just say export range. You don't have to do this, but we can define a minimum value of 0. Because you can't have 0 acceleration, and then we'll just say the maximum value of our acceleration, maybe just 50. Okay, and then our final variable here is going to be our step. This is for our slider. So, for example, our mass slider, if we move it across, the step is going to be 0.0001 kilograms, or 1 gram pretty much, but you can have it at 0.1 for now, and then we'll come over here, var acceleration. Have I typed that? Yeah, I think I've added 2 E's there. Okay, acceleration. This one, I like to keep it in uppercase, even though it is a variable that you can change in the doc. And we'll have it as float, and maybe the base value of 5, same as before. Now we're going to copy this line. What you can do really easily is go to the line and hit Control C and then Control V, and it copies the whole line. Alternatively, I think Control Shift D does the same thing and duplicates the line. So we're going to have the same values here for our acceleration, or for our speed, and we'll just rename it to speed. And I think I'll change it from 5 to 10. All right. So I did mention about some special methods earlier. What's it called? Our rigid body 2D has a method called integrate forces. This is the special method for our rigid body 2D, and it pretty much, if we come control and click on it, it says call during physics processing, allowing you to read and safely modify the simulation state for the object. By default, it's called before the standard force integration. Pretty much what that means is this is where we do our custom force application onto an object. If we want to have an impulse on the object, then this is where we would do it. So yeah, in this, I'm just gonna make this a little bit bigger for you guys to see. I think that's a lot easier to read now. Yeah, first what we want to do, we are we need the mouse position in order to change the direction and the rotation of it. So we can come over here and make a variable mouse, because that's going to be a vector2 as well, and there's a nifty function that is literally just get global mouse position. Here we go, get global mouse position, and then our what we're going to do is we're going to get the difference in the mouse position to the current character's position. To do that, it's called a resultant. We just need to minus the mouse position to the global position. So resultant. It's also going to be a vector2. This is going to have our mouse pos from before minus the global position. So global position is what that's referring to. It's a hidden variable here. It's our rigid body 2D's current position in the scene. So globally means not including the parent. In this case, the parent is the node, so it's pretty much the same anyways. But if you have a more complex scene, then that will matter. And we're also going to call dot normalized on this. Okay, that means same as before. If we go bottom left, or any diagonal, I should say, it's not going to move faster than if we just go down or up. Okay, what we can do now is we can call state dot apply force. I'm actually not sure that, I guess the apply force and apply central force pretty much would do the same thing. I never really saw this one though, so it's equivalent to using apply force and the body center of mass. Okay, I guess apply force just has more arguments where you can apply forces to maybe the corner of an obstacle or something like that. I think in this case, doing apply force and apply central force would just be the same, so up to you with which one you want to use. And for the argument, we're going to use resultant times the acceleration in this case. Okay. And then finally, we can use state.limit. We're going to calculate the speed here. Linear velocity.limit. Linear velocity.limit length. This is going to ensure that our character doesn't go too far, and we'll just have it as speed. Our speed value is going to be our max speed, so maybe I should rename it to max speed actually, just to make it a little bit clearer. And then finally, we want to actually rotate our player. Right now it's going to move around, but it won't really look at our cursor. So if you're making like a starship game where you want the ship to look at the cursor, then you would use look at and then just mouse pause, and that's it. All right, that is all you need in your rigid body 2D code. So what we can do now is come back to the scene view. We're still in full screen mode. I've hidden the other character body 2D just by toggling this icon. This disables the script and ensures it doesn't run, and also makes it invisible. So I've got our rigid body character here, and I won't add the camera yet. Is the rigid body perhaps too heavy? Let's see if that does anything. Okay, there we go. It was the now it's too fast. Okay, that's fine. This is too fast. The reason why it wasn't moving before was the mass of the rigid body 2D was too high. So maybe we can just have it at 0.1 kilograms and it will be fine. Sorry, I forgot to do that earlier, or I forgot to mention that earlier. But pretty much that will really depend, because we're doing physics calculations. The mass definitely matters. And if it's going too slow, we can up the value of the max speed or the acceleration, or we can tweak around with the mass here. Up to you guys. I think if we have 0.05, then we can look around. All right. What I'm going to do now is I'm going to have our character visible now, and we can see that both characters are actually moving, and they can collide with each other, and they can interact. So they're both moving at the same time, your arrow keys and your not your arrow keys, your WASD and your mouse. And our physics body is going to be nudging our character slightly too. Okay, that is really the basics of our Godot character top-down stuff. So what I would influence you guys to do if you're watching at home or if you're here is just have a tweak around with these values, decide which character you like more and you would implement, and then next tutorial we can move on from there and kind of generate the scene.